Hey guys, welcome to engineeringtalks.com. This is a short video on theory of simple bending. The previous video was about the introduction to pure bending or simple bending. You can watch that video in order to have an understanding of what is meant by pure bending or simple bending. Now, before we get into the theory of simple bending, we'll first go through the assumptions made in this theory. So the first assumption is that the material of the beam is homogeneous and isotropic. We all know what does homogeneous mean, right? Homogeneous means that the material is of the same kind throughout, whereas isotropic means that the elastic properties are equal in all the directions. Second assumption, Young's modulus of elasticity is same in all the directions. Third assumption says the transverse sections which were plane before bending will remain plane even after the bending. Fourth assumption, the beam is initially straight and all the longitudinal elements will bend into a circular arc with a common center of curvature. We'll discuss this in detail when we go through the expression for the bending stresses. And that will be in the next video. In this video, we'll go through the theory of simple bending only. Now, we'll move on to the fifth assumption. It says that the radius of curvature is large when compared with the other dimensions of the cross section. And the final assumption says each layer is free to expand or contract independently of the layer above or below it. So these are the assumptions made in the theory of simple bending. So here I have shown a part of a beam which is subjected to simple bending. Consider a small length delta x of this part of the beam. Also consider two sections AB and CD which are perpendicular to the axis of this beam. Due to the action of the bending moment M, this part of the beam will get deformed into a shape like this as shown in this figure. So from this figure, it is very clear that all the layers of the beam which were originally of the same length do not remain of the same length anymore. What does that mean? See, consider this portion of the beam between these two sections AB and CD. In this portion, you can see that all the layers of the beam are of the same length, right? Consider this portion between A prime B prime and C prime D prime. Here you can see that the layers are not of the equal length. The lengths are varying. The topmost layer AC has been deformed to a shape A prime C prime and it has got shortened, whereas the bottommost layer BD has been deformed to a shape B prime D prime and it has got elongated. So from this figure, it is very clear that some of the layers have got shortened while the others have got elongated. There will be a layer which will neither get elongated nor shortened, and that layer is known as the neutral layer or the neutral surface. This layer is indicated by Nn in this figure and by N prime in this figure. The length of this layer will not change. And the line of intersection of this neutral layer or the neutral surface on the cross section of the beam is known as the neutral axis. The layers above the neutral layer have been shortened, while the layers below the neutral layer have been elongated. Due to the decrease in the lengths of the layers above the neutral layer, these layers will be subjected to compressive stresses. And due to the increase in the lengths of the layers below the neutral layer, these layers will be subjected to tensile stresses. As you can see here, the maximum shortening has been taken place in the topmost layer AC. So this layer AC will be subjected to the maximum compressive stress. and the maximum elongation has been taken place in the bottommost layer BD. So, the bottommost layer BD will be subjected to the maximum tensile stress. As we move from the neutral layer towards the topmost layer, the lengths of the layers gradually decrease. And as we move from the neutral layer to the bottommost layer, the lengths of the layers gradually increase. So, the amount by which a layer increases or decreases in length depends upon the position of that particular layer with respect to the neutral layer or the neutral surface. This theory of bending is known as the theory of symbol bending. I hope it's clear. Please do like and share the video and subscribe the channel. Thank you.